Hello everyone. In this video, we are going to learn about the probabilistic generative models and probabilistic discriminative models. Probabilistic approach. So why we say them as a probabilistic approach? There is some uncertainty in the data and there is some data which is missing. So that is the name. We say it's a probabilistic approach. Generally, a feature X is given and this Y can be either 0 or 1. It can either belong to class 0 or class 1. Suppose if this X is representing some features of a person buying the computer. The value Y, it can be either yes or no. As per this representation, it says the person buying the computer is not certain. So we need to predict whether they buy it or not. It is because the label is not certain here. So this one tells us there is 70% probability that the person buys the computer and 30% probability that the person will not buy the computer. This will be represented like this. P of y is equal to 1, we have to find, given x is 0.1. So we have the features with us. We need to compute what is the probability for y to belong to class 1. So given a feature x, we need to find the uncertainty in the label y. We need to check whether y belongs to class 0 or class 1. It's a very simple notation to represent it. We need to calculate the probability of y where the feature x is known to you. Feature x is given to you. These kind of models is what we call it as discriminative models. They are a type of ML model which is focusing directly on predicting the label or output from the input data. So this is designed to find the boundary or the relationship between the different classes without modeling the underlying distribution of the data. Consider X having two features here, 18 and 5000. So these are all the two features, age and income. These are all the corresponding weights for those features, 0.05 and 0.01. Generally, in case you want to compute the probability of y given x is equal to these two features, we will compute the feature along with the weights. We will sum it up. Later, we'll have to pass it on to a function. A function is applied over this calculation to bring in the range, say 0 to 1, so that we can predict whether it belongs to class 0 or class 1. Suppose we toss a coin, probability of getting a head or a tail is 50%. Suppose if the weight is more for head, the probability for head will increase and the y will obviously end up in class 1. When a new test data is coming in, as given here, a new test data comes in with some new values, we will use the very same function to compute to which class it belongs to. So given x, we will be able to find the probability of y, and that is what we call it as a discriminative model. Generative models, as the name implies, we will be able to generate new data. For example, P of x comma y, that is the joint distribution of x and y. This is one example. See, probability of x is equal to 18 comma 5000. So for these features, this y tells that it belongs to class 1. For each of x and y, new probability can be fixed. So using this uncertainty, new pair of x and y can be generated. That's why it gets the name generative models. In discriminative model, x is available, but we don't know the probability of x. So it's not possible to generate x comma y. But here we know both x and y. So we will be able to generate new pair of x comma y. Let us compare the generative models and discriminative models. Generative models is we are trying to understand the data distribution, whereas discriminative models we will be modeling the data decision boundary here. Data decision boundary. And the generative models we use joint probability. Discriminative models we are using conditional probability. Generative models in terms of computation it's expensive. Discriminative is comparatively, relatively it's cheap. This generative models we use it for unsupervised tasks, whereas discriminative specifically for supervised, that's for classification. Yeah, this is harmed by outliers. It's more robust to the presence of outliers. This models, generative models, it shows how the data is placed in space, whereas this discriminative models, it generates boundaries around similar classes of data in space. This is about the comparison of generative models and discriminative models. So in this video, we have seen what are discriminative models and generative models. So discriminative model says we need to find out the probability of y given x. Whereas the generative models, it's probability of x comma y, which is the joint distribution of x and y. Also, we have seen a comparison of these two models. Thank you.